Hello everyone and very warm welcome to this amazing session at PW. My name is Aman, your favorite maths buddy, and we continue our journey to revise the chapters which we have already learned. Today we have come up with the chapter of pair of linear equation. Now before also we have learned about linear equation, but those were the simple equation. In this chapter what we have dealt with, in this chapter we are dealing with the two variables. This is a new concept. We are dealing with two variables, and to understand two variables and get the solution of it, we will be needing a pair of linear equation. So this is a new thing in this chapter. Other than that, this chapter is a lot more interesting chapter because this chapter on its own solves multiple real life issues. Now for that we need to understand first of all how to frame a linear equation. If you are able to form a linear equation, then you can understand how to solve the linear equation. So these are the things which we are going to learn in today's session, and I hope you are sitting with a paper and pen because there would be a lot of calculation in today's problem over here. This is an important session you have to solve because other than that there is no concept, there will be no formula like the previous chapter. This is a direct straightforward calculative problems here we are going to solve. So what are the content, what are we going to do? First of all, I am going to introduce you to the part what are linear equation, then I will be telling you about what are solution, and finally most importantly what are the methods we have to get the solution. So the first thing we will be talking about for the finding the solution is graphical method. We will be forming graphs and trying to understand how to get the solution from the two equations. Once we are done with the graphical method, we know that method is not feasible every time. It's not that each and every question coming from pair of linear equation in the examination hall you will be provided with a graph. Every time you will be plotting a graph and solving. That's not feasible, right? So we will be going forward to the substitution method and elimination method. Both method very easy to understand, very simple to understand. Only thing is a consistent effort from your end to try to solve the problems. Alright, so on that note, why waste another lot more time? We should start the problem, right? Now first thing I want to address is, till now I mentioned you have already learned simple equation. Simple equation, as the name suggests, are very simple to go. So very simple how? Let's say we are sitting in a classroom. In a classroom I gave you the account that total 50 students are there. If total 50 students are there and I mentioned to you that out of 50 students 30 were boys. Now you can think about it in this manner. Let's say there are x students who are girls, and you can find the value of x. How? By simply subtracting the number of boys from the total number of students, right? So this is a very simple equation. If I give you a triangle, in a triangle I give you two angles, 1 and 2. Now you want to find the third angle. For that what we need to do? We know that the property of angle sum, property of triangle is that the three angles would be equal to 180. You can easily find. So in this manner simple equation is lot more simpler. But what happens when we enter into the pair of linear equation? You'll understand. Read it out over here. Read it out. Sorry. So over here it mentions if the number of girls in a class is 4 more than the number of boys. Alright, number of boys and number of girls relation is given to you. Fine, very simple. So if I say the number of girls are x, not x, let me assume that the number of girls are y. This is number of girls. I am assuming this part. Number of girls being equal to y. Now what will be the number of boys? Write down in your notebook what will be the number of boys in this case. Number of boys. Can you directly find out? Basically the relation is given. If I have assumed it to be y, let me start by assuming the number of boys to be x. Alright, if I assumed it to be x, now what? In terms of x and y, I want to form a mathematical relation. In terms of y and x, I want to form a mathematical relation. Now, if the number of girls is 4 more than the number of boys, who is the greater quantity? Which is the greater quantity? Number of girls are greater or number of boys are greater? Because when you have to convert a English statement into the mathematical form, you should be very thorough. Who is greater? Number of girls or number of boys? Clearly mentioned the number of girls in the class is 4 more. Girls are more. So definitely girls is a greater quantity. So if I want to form an equation, I should be very clear where should be I adding 4. Because if I add 4 to the higher quantity becomes more. It's like you are buying a vegetable and the balance is something like this, where we need to put up the weight. We need to put up the weight on this side so that it becomes balanced like this. Now, if the balance is something like this and you put the weight on this one more, I put the pen on this side. So this will further go like this, right? So to make a balance, the equal weight should be put on both the sides. So if I say y would be equal to what? Y would be equal to x plus 4. Why x plus 4? Because x is the smaller quantity, and so that it becomes equal to y, I have put 4 on this side. I have added 4 on this side. So y equals to x plus 4. Fine. What we have done? We have formed a linear equation. This was asked in the problem. Write the linear equation representing the information. We have written a equation over here representing the given equation to us. Fine, very simple. But the next problem over here, the next statement over here creates a confusion. What it says? It says also find the number of boys and girls. Number of boys and girls. Now, y is equals to x plus 4. That part is fine. But how would I get to know the value of x and y? Because the number of girls and boys would be y and x. And for that, we need to have some other information. Why I'm saying so? Because the relation we have found out is y is equals to x plus 4. If I put up any value of x, I'll get a different y. So let me say that x is equals to 0. That means there was no boys in the classroom. It was only a girls class. Right? So x equals to 0. So the total number y is equals to 0 plus 4, y is equals to 4. So in this case, the number of boys and girls come out to be 0 and 4. 0 being the number of boys, y being the number of girls, so that come out to be 4. So if I say that, okay, the number of boys were 5. Now, the number of girls would be what? The number of girls in this scenario would be 5 plus 4. Because I have placed the value of x. That's what I am doing. So 5 plus 4 is 9. In this case, y, that means y, the number of girls come out to be 9 and the number of boys 5. So basically, if I change the value of x, the change would be there in y as well. So in this manner, I cannot pinpoint the number of boys and girls because it will keep on changing. But that cannot be a real case scenario. That's not the real case scenario. So basically, something is missing because using this equation over here, if I go to plot a graph, I hope you remember the graph plotting. How do we plot a graph? If we have, listen very carefully because these steps are very, very important because our next understanding would be graphical solution. How we can approach the pair of linear equation using graph. So for that, we need to understand how to plot a graph. This is given to us, y is equals to x plus 4. Very simple equation, fine. In this, what we need to do? First of all, form a table like this. X value, y value. This is x value, y value. Fair enough. And in this, we have to find out different x value for different y value. Or you can say vice versa. So, if I assume that the x value is 0, if I assume x value to be 0, what will be the value of y? I hope you can solve on your own in your notebook. I have done just now, previously. So, putting up 0 over here, the y value will come out to be 4. Very good, very simple thing. If I take x value to be 1, what will be the y value? It will be 5. If I take x value to be 2, it will come out to be 6. In this manner, you can form as many pairs of x and y. Pairs? Yeah, basically the values 0, 4, 1, 5, 2, 6. I hope you remember some of the Cartesian plane. Right? So over there, we need the value of x and y to do the plotting of particular point. Now, what is this plotting of point? What exactly these points 0, 4, 1, 5, 2, 6 represent? This we generally say the solution of the given equation, or I would say the line. Why line? Let me plot these points on the graph paper. So here we have 0, 4. So this is 0, 0, 4, somewhere over here. This is 1 point I have plotted. 1, 5, 5, somewhere over here. I hope you remember the first part is to move on the x-axis. So the x value is 1. So I move from the origin 1 point on the right side. Why right side? Because it was positive. If it would have been negative, I would have moved on the left side. So now we have 1, 5. After moving on the right side, you have to move vertically. If positive, upwards. If negative, downwards. So over here, we move upwards. How many points? 5 points. Fair enough. Next, 2 comma 6. Same step being repeated. Only you have to understand the algorithm. Once you have understand the algorithm, okay, after this step, this step, this step, this step, this step, this step, and you will able to form the answer from here. So 2 comma 6. Next is moving 2 units on the right side, going 6 units upward on the y-axis. These are the 3 points. Why I have plotted 2 points? Because I can plot a line using 2 points. I only need 2 points. I need to connect these 2 points to form a line. But I have taken 3 points over here. My suggestion to everyone would be that you take 3 points, because in case you are doing any calculation error, which is very obvious with most of the students, they end up doing some kind of a calculation error. So in case you are doing any calculation with error on any of the given point, you will end up forming a different set of line, because the line correct line would be like this, and if you get the wrong point, let's say 1 point over here, second point over here, you'll end up plotting a line like this. What happens when we have 3 points? When we have 3 points, in that case, if any of the 1 point is going haywire, rather than going over here, it comes out to be here or come out to be here, you will realize that okay, this line is not possible, and you will check on your own what mistake you have done. So in this manner, 3 points are better way to go forward to form a line. Now these points I am connecting and forming a line over here. I am not using a scale, so please don't ask me, so this line doesn't seem to be straight. There is a curve kind of a thing. No, alright, this is a straight line where 3 points are being connected. Now these line, whatever points are on these lines, they are the solution. If I say this point over here, whatever point are there on the given line, whatever point, this point, this point, this point, this point, here, here, all these points represent the solution of the given equation. Why? Because solution simply means that value of x and y that will satisfy our given equation. So there can be multiple values of x and y. But coming back to our problem, they were asking the number of boys and number of girls. In a classroom, that's not possible that the number of boys and number of girls keep on changing in academic year. Each and every academic year, the things might change. This year, the number of boys and number of girls were different. Next year, it might be different. But that cannot be the case every time. In a same academic year, things will remain stagnant, right? So if we have 10 boys, there might be 5, 7, 8, 9 or 12 girls in a particular academic year. So basically in the given question over there, something was missing, because we want a unique solution. Now this is a new word, there is a new catch, unique solution. When I was plotting this line over here, there were multiple solutions, but I don't want multiple solutions, I want a unique solution. For unique solution, we need a pair of linear equation. We cannot solve just by one equation, we need a pair of linear equation. So here we have another information coming up that says that the total number of students is 10. Now, if we have number of boys, number of girls in terms of x and y, and we know that the total number of students is 10, I can form another equation. The equation would be simple: x plus y equals to 10. This is one equation using this information. Previously, we have already formed the equation y equals to x plus 4. And this is our first linear equation, this is our second linear equation, both having two variable, one being x, another being y. And always remember what you have assumed: x was the number of boys and y being the number of girls. If you have these two equations, now when you go for the solution, there will be multiple solutions for equation 1, there will be multiple solutions for equation 2, but equation 1 and 2, they will be intersecting at some point, which will be a unique point. What does that mean? I simply mean the value of x and y, I can find out in a manner such that it satisfies this equation as well as this equation. For both the equation it should work. So now I have already plotted for first. Let us try plotting the second equation. This would be very simple. We have x plus y equals to 10. So for this I can do the plotting. Very easy to find out the points over here. you can find as many points you want. You can find as many points you want, but you need to have at least 2 points to plot a line. But I would suggest one extra or additional point. So over here, if I say x is 5, x being 5, what will the value of y? X being 5, 5 going on the other side, 10 minus 5, y value comes out to be 5. I am not doing the simple equation part because I know that you have done already this multiple times. It's up to you whether you are solving in your notebook or not. I would suggest if the question is having a huge weightage. Weightage means it might be of 2 marks, it might be of 3 marks, it might be of 5 marks. So according to the weightage, do the solution. Basically, the subjective solution depends how lengthy you want to make it, how very obvious and clear you want to make it, each and every step. 5, so this value comes out to be 5. If I say this value is 6, so what will be the value of y? Y value come out to be 4. If I say x value is 7, so the value comes out to be 3. Or if I say, let's say this value is 3, the y value will be 10 minus 3, that means 7. Multiple points. Very simply, you can find out multiple points and move on to the part of plotting. Let's do the plotting now. We were having few points. 5, 5. We were having 5, 5. 5, somewhere over here. Alright, 5, 5. Another point was 6, 4. 6, 4 over here. We were having 3, 7. Let me draw a line for this one. This would be something like this. I hope this time it seems to be a straight line. Now, I can merge the two graphs, this graph and the previous graph which I have plotted. I have plotted this one. This graph also I have plotted. Over here, I need to see the intersection. If I see the plotting of this graph 0, 4, 1, 5 and 2, 6. All it. I am going to plot it 0, 4 to 1, 5. 0, 4 over here. 1, 5 somewhere over here. And we had, I think something like that was y equals to, we can find out the solution once again, it was y equals to x plus 4. So if I say y, if I want to find y for x equals to 3, what will happen? Y will come out to be 3 plus 4. That means y will come out to be 7 over here. So another point which I found out is 3, 7. Let's plot it. So here we have 3, 7. Here. So this is our third point. Let me plot the line over here. This is something like this. And we have done the plotting of two lines. Now we can observe one thing. I was talking about a specific term that was unique solution. And I told you a unique solution is the one where the x value and y value will be satisfying both of the given equation. Now, if you observe the given graph over here, there is one point which is common, or I would say intersecting point. Intersecting point means this value over here will be the value of x and y, which would satisfy this given equation as well as this given equation. And that particular point, if you observe, is 3, 7. The reason I started solving again for this given equation because I can realize that okay, 3, 7 might be the solution. You might say, sir, you already knew or what? No, I didn't knew. But if you start solving the given equation, start plotting the line, you will realize somewhere it will be intersecting, and you don't need to exactly pinpoint directly. Automatically wherever they intersect, that will be your solution. That will be your unique solution for the given problem. So 3, 7 is the unique solution for the given problem. Now I can say the number of boys in that class would have been 3 and number of girls in that class would have been 7. And that is the reason the total number of students 3 plus 7 comes out to be 10. And when you see the relation, basically the number of girls are 4 more than the number of boys. So everything is clear with this solution of 3, 7. This is our unique solution, and for the pair of linear equation, we do require a unique solution. And that is the reason we had formed two equations. I hope you have realized the importance of pair of linear equation and why do we need them in real life. There can be multiple cases where we need to form pair of linear equation. One example I can give you, a very simple one. Let's say you went to a stationery to buy some pencil and some pen. So basically, if you have two unknowns over here, you don't know the cost of a pen, you don't know the cost of a pencil. So if I say you bought 2 pen and 3 pencil, that costs you 15 rupees, that costs you 15 rupees. And on the other scenario, you bought 5 pen, and 10 pencil, that costs you somewhere around, let's say 75 rupees. Now, using this much of information, tell me the cost of pen and pencil. This obviously is a question of pair of linear equation. Why? Two unknowns, two equations will be formed using the given information to you. You have to ultimately find x and y. But x and y forming the line over here and finding the unique solution would be a lengthy thing. We'll talk about it. But in the graphical solution also, I need to address one important point. Over here, the two equations which we were having, and while plotting, we get this solution. But that will not be simple all the time. Things will not lie in the same case every time. So what are the other cases? Let's see. So over here, this time we have a different equation. We have a different set of equation. 3x minus 2y equals to 6, 6x minus 4y equals to 8. What we need to do? We need to again find out the solution. And how do we do that? Basically by plotting. Now, everything I cannot give it to you. I cannot spoon feed you, right? So you have some work on your own to do. For this pair of linear equation, what I expect from you? I simply expect that you will pause the video and start solving the value of x and y such that you can plot on the graph. And while doing so, you will realize how to go forward with the graphical solution. But my point over here would be different. What I want to address by this given equation? The thing I want to address by this given equation would be, let's say when you go to plot this particular point, you will realize something like this. One case was there when the two lines were intersecting. That is not possible every time. Sometimes what might happen, let's say you plot one graph. This color doesn't work well, so let's change the color. You plotted one equation, it comes like this, fine. You tried plotting the other equation to find out the unique solution, but that was a gotcha moment. Why? Because when you go forward for the plotting of that particular line, you realize that the equation when plotted comes something like this. Basically, these are two rails on a railway track. They will never intersect. If they are never intersecting, the obvious thing is they will not be having a unique solution. That means there will be no single value of x and y that will satisfy both equations. For one equation, there will be multiple value of x and y that will satisfy. For another equation also, there will be multiple values of x and y. But there will not be a unique solution that will satisfy both of the formed equation. And in this particular scenario, when you do the plotting and you find out the lines of this form, this manner, you will realize these are the parallel lines. So when we have parallel lines, the solution will not be unique. Or rather, I would say there will be no solution. There will be no solution at all. First was the case of unique solution, where we had a unique solution. Another is the case where we don't have any solution. So it might be possible that whatever information was given to you, that was just to cheat you. That given problem set does not have a solution at the first place. That was just to check whether you know how to solve and try the problem given to you. And such scenario, how will you observe? When you observe there is a parallel lines. When you do the plotting and when you observe that the parallel lines are there, you will come to the realization that no solution was possible. This was the second case. Now, the third case you can think on your own. What can happen with the two lines? Either the line will intersect, either the line will go parallel. What other third scenario is possible? And I hope by now you have already done the plotting. You have not realized on my part that, okay, I'll be doing the plotting for you. I have told you the basic method. I have given you the algorithm. You have to repeat the algorithm again and again. Third case, I am moving on. And again, I am bringing up a new set of equation. I am again bringing up a new set of equation for you to practice again the graphical solution, so that you become expert, and just by seeing the equation, you can quickly do that part. Now, when you go up to plotting of these two equations, there will be a new scenario coming up. There will be a new scenario coming up. What will be that new scenario? Let's see. The third scenario which will come up to you would be something like this. You plot a line. This is your line. I hope it's visible. You plot the line, it will come something like this. Fair enough. Now, when you go for the plotting of the second equation, what happens? When you go for the plotting of the second equation, you will realize what did you do, sir? You haven't drawn a new equation. You have simply just traced the previous one. But, yeah, that can be the third scenario. The two equations given to you are basically the same equation. So, understand in this manner. I have written over here 2x plus 4y is equals to 8. 2x plus 4y equals to 8. Now, if I multiply this entire equation, by 2, and the new equation coming to me will be 2 into 2, 4x, 4 into 2, 8y is equals to 16. These two equations were given to you and were asked to do the plotting and find the solution. Initially, you didn't realize because you were very eager to apply your algorithm. But your algorithm did work, but you didn't find the solution. You felt that, okay, your effort was waste. Your effort was a waste of time basically, because the plot was a single line. This is not a single line. I can make you understand that basically these two lines are coinciding. One line above each other. And why is that happening? Because there is extra coefficient over here. The coefficient is basically 2 over here. If you multiply by 4, if you multiply by 8, if you multiply by 1 or minus 1, the line plotted would be similar. Because we have just multiplied or divided the equation, that doesn't mean the plot will change. Because on the beam balance, if 1 kg was put on this side and 1 kg was put on this side, so if I put another 1 kg on this side and another 1 kg on this side, now the beam balance is having 2 kg and 2 kg. But the balance is there. It doesn't change. And if the balance doesn't change, the line will not change. The plot of the line will remain same. So now I hope you have again done the plotting of the two equations which I have given to you for this scenario. But ultimately, if I have to summarize what I have told till now, I have told you 3 cases. And the 3 cases can be represented in this manner. 3 possible outcomes. Any of them might be possible. Anyone of them might be possible. The first case which I helped you trying forming up the graphs was this one, where the lines intersecting. When the line intersect, we call that as one solution, or correctly mentioned as a unique solution. And unique solution is the thing which we try to find out in most of the cases. So this is our case of unique solution. This is the case where the two lines are parallel. When the two lines are parallel, one thing is for sure, that the line will not be giving us any solution because there is no intersecting point. And the third case comes up where the two lines coincide. When the two lines coincide, basically that means there is extra coefficient in the two equations, nothing more than that, because the two equations are similar. And hence we can say that we have infinitely many solutions. Why so infinitely many solutions? Now, what does infinitely many solution means? I told you when we have a line, there would be a line is made up of multiple points. If I draw a line like this. So basically what it is a connection of multiple points. And these multiple points are what? These multiple points are basically the values of x and y. So x and y, there can be infinite value of x and y which will satisfy this given equation. There will be infinite value of x and y which will satisfy this given equation. Fair enough. And hence, when I say that the two lines coincide or the equations are same, that means there will be infinite solution for it, because you can put multiple value set of x and y which will give you a fair solution. And that's the answer for you. So two sets are there: unique solution, multiple solution, or you can say infinite solution. In between we have no solution. And these are the three possible cases for the pair of linear equation. And how do we realize it? By plotting on the graph, and hence this is the method of the graphical solution. The graphical solution. As I mentioned, there is a problem with this method. What is the problem? It takes some time. Every time I will be requiring a graph paper, I will be wasting one graph paper. My parents would be scolding to me, why wasting these papers and all. So for that we have a more convenient method. And basically we have two methods which are more convenient. The first method which we come up is called as the substitution method. We'll talk about substitution method. First, quickly answer few of the very easy questions. The question over here says, after plotting the respective graphs of the linear equations in two variables, what should we do to find the solution? So they are saying you have wasted your time plotting the graph and you have formed two lines. Now once you have formed two lines, now what will be the next procedure? How will you find the solution? Please read the options over here carefully and think about the correct answer. I hope you have got your correct answer. Find the area of the triangle made by the lines in the coordinate axis. This is out of the syllabus. We haven't found out any area using the plotting. This was not there. Find the coordinates of the point of intersecting of two lines. Basically they are saying you need to find the coordinates of the point where the two lines are intersecting. Yes, this we have done. So we don't need to go forward. This will be our correct option, right? Option number B is the correct one. The intersecting point having some coordinate, and that represents the solution for the pair of linear equation. Very simple and a theoretical question. One more theoretical question for you. A pair of linear equation represented by x equals to a. Yes, this is a equation. When you have to plot the graph, this equation is sufficient to plot the graph, x equals to a. And another equation is y equals to b. Now, when you plot these two graphs graphically, then the lines are what? Are they parallel? Are they intersecting? Are they coincident? Or they are intersecting at these two different points? What do you think? For this, first of all, the concept of coordinate geometry should be very, very clear. What do I mean? X equals to a. Let's do the plotting of the graphs over here. Let's do the plotting of the graph. This is a Cartesian plane. I hope you know that this horizontal line is the x-axis. This vertical line is the y-axis. On the right side, we have all the positive number. On the left side, we have all the negative numbers. Towards upside, we have all the positive number. Toward downside, we have all the negative numbers. Now, x is equals to a. So basically when we talk about equation which is having two variables, there are x and y. There is x and y. But here I can find only x. There is no y over here. If there is no y over here, so when I do the plotting of x equal to a, so let me say I am plotting it over here. X is equals to a. So what does that mean, sir? X is equals to a. So first thing what we do is we move on the right side or left side depending upon positive value or negative value. A seems to be positive, so let me move on the right side. So somewhere over here I assume that we are having x equals to a, because a can be any value. It can be 1, it can be 2, it can be 3. So here we have x equals to a at 0. Now y is not given to me. I assume that y was 0. But now let me assume y to be 1. So for this particular point, again the value will be somewhere over here. For y to be minus 1, still the value will be here. For y equal to 5, still the value would be here. For y equals to minus 5, the value would be here. What I am doing? This is a very simple thing. Whatever value of y I take, because y is not given in the equation, for whatever value of y I take, this thing remain constant. The value of x remains constant, x equals to a. For each and every value of y, the value of x will remain constant, and hence I can do the plotting of this particular equation, and I will realize that this line comes out to be parallel to y-axis. So if I say x equal to a, So whatever value of x is given, that will be line parallel to y-axis. If I say x equals to 5, it will be parallel to y-axis. If I say x equals to 1, it will be parallel to y-axis. If I say x equals to minus 1, it will also be parallel to y-axis, because it will just shift on this horizontal plane, but vertically they will always remain parallel. Now for y equals to b, I want you to apply your brain. For y equals to b, I want you to apply your brain and understand how would be the line for y equals to b. If you think about it, just exact opposite. Here, the value of y is remaining constant for whatever value of x is there. For whatever value of x is there, the y value will remain constant. Since y is positive, so it would be upwards. So the line if plotted would be something like this. Something like this. Now, what is happening over here? This is a x equals to a. This is our x equals to a. And this is our y equals to b. What is happening? These two lines are intersecting at one point. These two lines are intersecting at one point, and this is our intersection point. What do you think? What is the coordinate of this line? Not line exactly. What is the coordinate of this point over here? If we realize the value of this point over here from 0 to this, how much is the distance? How much is the distance on the x-axis? You can easily see x equals to a. Every time the value of x was a. So basically from 0, or I would say origin, this point is a comma 0. A comma 0, right? So a comma 0, the value of x on this particular line is x equals to a. Fine. For this equation, for this line over here, I know that how much distance it has from the horizontal plane. Over here we know that y equals to b. So this line over here will be having a coordinate of 0 comma b on y-axis, and if you remember Cartesian plane, you will realize if I know this much distance and if I know this much distance, which I already know, the point x value is a and the y value is b. A comma b is what? A comma b is the intersection point, and that is what been asked in the problem over here, intersecting at b, a comma b. Now basically what I have done for the past 5 minutes, I have made you revise the coordinate geometry if you don't know. If you don't know, I have made you revise the coordinate geometry. I have told you the very basics of x-axis, y-axis, and how to do the plotting for a constant line, constant equations over here. Very simple, where the value is constant throughout. Alright, let's not waste any more time and move on to our easier methods where we don't need to do the plotting, because plotting would be much more easier, and since we have learned already the coordinate geometry things, so you will be more comfortable for that. Let's go on to the method where you can use your paper and pen to easily find the solution. For that we have the substitution method. Now before talking about substitution method, you might getting restless for this part. One more thing I want to mention. What more thing? For the two pair of linear equation, I told you that we can have parallel line, we can have a line coincident, and we can have two lines being intersecting. Sir, but how will we realize that what kind of a case is it? Because every time I cannot go and plot the lines, because that will be a long process. I will be wasting my time over here, because we are talking about precious time. For that we have a direct understanding. What we do? For that we have to observe the coefficient. of the two pairs of equation. See, understand it over here. This is a general form of a linear equation in two variables. We have x, we have y. What is a, b and c? A, b and c are nothing but the coefficient of x and y, and c is the constant value respectively. Now if I talk about the another equation, because we are dealing with a pair of linear equation, so another equation will also look like this. But how do we differentiate, sir, a and b? Because in this equation we have a, in this equation we have a. For that, what we have done, we have named them a1, a2, b1, b2, c1, c2. Now we can differentiate the coefficient of x in the first equation, the second equation. What we need to do to understand what case scenario would be there, we need to compare the ratio of the coefficient of x with the coefficient of y with the ratio of the constant value. Basically, we need to find out the value of a1 by a2. You need to find out the value of b1 by b2, and you need to find out the value of the constant ratio. C1 by C2. If you observe that the ratio are not equal for x and y, if you observe the ratio are not equal for x and y, in that scenario, that case is for the unique solution. That case for the unique solution. If you observe, if you want to observe, just think about the first case. Just think about the first case where we did the plotting part, Over there, the coefficients of x and y were not equal. Over there, the coefficient of x and y were not equal, and we got a unique solution. In this case, we have a unique solution. So a1 by a2 is not equal to b1 by b2. And when we go on to the plotting part, we will find a unique solution where the two lines intersect. Another case is the case where we don't have any solution. No solution was the case where the lines were parallel. For the parallel lines, the ratio of x and y is equal, but the ratio is not equal to the constant value. So a1 by a2 is equal to b1 by e2, but it is not equal to the ratio of constant. So over here you can observe these two ratios are equal, but these two ratios will not be equal to this particular ratio given to us over here. This is the case of no solution, or you might say parallel line. And finally, the case where the two lines coincide. I think you should not ask me for this part because I have already recited this part, that the coefficient was multiplied to it and the equation changed, and that is the reason we got a coinciding line. So basically, for the particular case of coinciding line, all the three ratios would be equal because nothing have been changed in the given equation. Only either the number was multiplied or the number was divided in that particular scenario. These are the three cases which you have already learned, and just by observing the equation, by taking the values of the ratios of x and y, you can find out which case it lies. One more thing I want to mention. Unique solution is there. If we have a solution, we would say that it is consistent. So unique solution and infinite solutions are consistent, and the case of no solution is inconsistent. This is inconsistent. Over here we have a unique solution, we call it to be independent, and in the other case where we have a solution but they all are infinitely many solutions, we call it as dependent solution. So two new words dropped over here: consistent, inconsistent, dependent, independent. Very easy and simple to understand. Make sure you understand the clarity among these two terms, because in mathematics they don't ask you directly these kind of a question, but they might use them in the form of questions like, okay, find the independent solution or find the consistent solution of something of that sort. So you should be very clear about the term. You should not be confused at that moment. What are they talking about? Alright, so I hope you have taken the note of this or the screenshot of this particular slide over here. We move on to the next part where we need to mention what kind of a solution would be there. Determine the nature of the solution. So just by seeing the equation, you have to mention whether we have a unique solution, no solution, or infinite solution. So as I mentioned, a1 by a2, find out the value of b1 by b2, and find out the value of the ratio of the constant. From the two equation, x is having a coefficient of 2. X is having the coefficient of 2. So a1 value is 2. What about a2? Think carefully over here. Many of the students will directly say, sir, 9, 2 by 9. Bache, be careful. This is 9y plus 3x. You can have a different way of framing an equation. You can have a different way of writing an equation. This equation is 3x plus 9y or 9y plus 3x. Both are the same thing. But a2 is the value of the coefficient of x. So over here, 9 is not the thing. We are looking forward for 3. 2 by 3. This was a1 by a2. For b1 by b2, 6 upon 9. So I will write it over here, 6 upon 9. But this is not in the reduced form, so I need to cancel it out by the lower highest common factor over here, which is 3. So 3 dividing 6 is 2, 3 dividing 9 is 3. 2 by 3. a1 and a2. a1 by a2 and b1 by b2 have come out to be equal. Let's now observe the final thing, that is c1 by c2. One thing is very obvious, the signs are different. This is positive, this is negative. They can never be equal to these two ratios because these two ratios are having the same sign of positive. Now if you realize where a1 and a2 were equal to the b1 by b2, what was the case? If you don't remember, you can go back over here and realize this was the case. Where we have no solution, I can say the pair of linear equations were inconsistent, and hence the answer in this scenario is no solution. Very simple thing. Alright. I hope things are Clear, crystal clear over here. Now is the time. You have waited a lot to realize how to go forward for the substitution and elimination method. So now we start with the substitution method. The name itself, substitution, suggests a lot. We have to substitute one thing for the other thing. So when a footballer is playing for a very long time, he got tired a lot, and the manager thinks that now he's not that efficient, let's replace it with some other player. And they make a like replacement. So if a forward is there, they'll replace it with a forward player, right? So this is something of the sort of substitution. Something of the similar nature we are going to do over here. We are having two variables, x and y. So we have to basically find out the relation of x and y, and I can replace the value of x with the y1, or I can do with a vice versa. And of the theory, sir, let's observe by doing it. The two equations are given. The first step for the substitution method, 2x plus y equals to 6. Write one of the variable in terms of other. So write y in terms of x. I can transfer this 2x on the other side. I'll write it as y equals to 6 minus 2x. Y is equals to 6 minus 2x. This is our first step over here. Always write one of the variable in terms of the other. Y is equals to 6 minus 2x. So this is our first step. Done. Now in the second step, we have to replace the value of y with this value in terms of x. So let's take the second equation. This is 3x minus 2y equals to 2. I'll replace the value of y with this value over here. So putting up the value of y over here, this will come out to be what? 3x will remain as it is. I am putting the value of y, replacing it with this value. So taking up this value over here. This is 2 multiplied by, I am taking in bracket so that you don't end up with any calculation error, because we are having a negative sign. Most of the students make this common mistake. Writing it 6 minus 2x. 6 minus 2x equals to, we have the same thing, equals to 2. Now open up the bracket, do the multiplication and start solving, because now it is converted into a linear equation which you are very comfortable solving, because you don't need any revision to start solving the linear equation, simple linear equation. Here doing the solution part, 3x minus this 2 multiplied with 6, so this will come out to be 12. Minus will become positive, because this is the common mistake which you have to avoid. Minus plus 2 into 2 is 4, 4x equals to 2. Now we have 3x plus 4x, this is 7x, and this minus 12 will go on the other side and will become positive. So 2 plus 12 become 14. From here I have found out the value of x to be simply 7 dividing 14, that's come out to be 2. X value we have got, we need to find the solution. We have taken the first step and we have got to the halfway. It's not obviously halfway, we have already done 90% of the calculation. Now x equals to 2, we need to replace. This was the second step done. The third step is to find out the value and put it back into in terms of this given equation which you have find out. So y is what? Y is equals to 6 minus 2 into 2, 2 into 2. That is y equals to 6 minus 4, that means y equals to 2. Alright, so basically both the solutions of x and y value comes out to be same. X come out to be 2, you have placed the value over here, 2 into 2 is 4, 6 minus 4 is 2. So y is 2 over here, and the point which we need to find out, that is x comma y, is what? 2 comma 2. This is our ultimate solution. Without going for the graph paper, without doing the graphical solution, we have found out the solution. Repeating all this step once again, a bit of calculate. I will not say a lot more calculation, a bit of calculative process. What we do, two equations were given. Write one of the variable in terms of other. So write y in terms of x. Write y in terms of x. Once you have written that, now put the value of y in the other equation. I replace y with the value in terms of x and start solving. Now when you start solving, basically you have converted this linear equation in two variable, in one variable, so you can find out the value of that one variable. I find out the value of one variable. Once you have find out the value of one variable, now you can replace the value in the equation which you had formed. You get the solution, you get the value of x and y. These methods can only be learned by practicing, because this is not a formula which you can apply anywhere. So let's not waste any more time and try to solve the equation given to us over here. Determine the value of y satisfying both the equation. So basically, satisfying both the equation means that we need to find the solution of the pair of linear equation. In this given equation, already we have been given that y is x plus 6. The first step is already done. The problem is much more easier for you. One variable is written in terms of other. Replace the value of y in the second equation with the part which is representing x. So 2x minus y equals to 4. Putting up the value of y, so this comes out to be, I am putting up the value of y in a different color, so you have a realization over here. Negative sign is there. Always use the bracket. X plus 6 equals to 4. Now solving this linear equation, 2x minus x minus plus minus 6 equals to 4. 2x minus x is simply x. This 6 going on the other side, 6 plus 4. This is 10. X value is 10 over here. I am putting this x value in this given equation over here, and I will find out the value of y. Y will be x plus 6, so replacing x with 10, 10 plus 6 is 16. This is the ultimate solution which we are looking forward to. We have option number C correct. Nothing I have done. Problem was very simple. The first step was given to you already. No need to go forward for that. Replace the value of y in terms of x in the second equation. Find out the value of x. Once you have found out the value of x, put up back in that same equation and find the value of y. Only y value was found. Anyhow, you have to find both x and y at the same time. Very simply done. This is what substitution method is. On its own, it's not complex. 3 steps you have to follow, a basic algorithm, and you will reach to the correct answer. Next problem. I'll ask you to pause the video and try solving on your own, because this problem is very simple. The only thing which you need to learn from my end is how to proceed with the calculation without ending up with any mistake. So what I have started with, the second equation is x minus y equals to 4. So x minus y equals to 4. I have taken this y on the other side. Why every time y equals to, why are we replacing y every time? This time I want to replace x. I don't have any friendly nature with x. I am playing equal with x and y. So x equals to 4 plus y. Now I can replace this value in the first equation. The first step is done. So x plus y is given to you, the sum is given to you as 14. This case, I'll replace the value of x. This case, I'll replace the value of x. I'll replace it with 4 plus y. 4 plus y equals to 14. Don't forget this y. Few students might end up with this mistake as well. So 4 plus y equals to 14. So this comes out to be y plus y is 2y. This 4 goes on the other side, which is 14 minus 4. And from here, the value of y is 14 minus 4 is 10 by 2. And we get 5. Y value is 5. Replace in the x equation. Putting up in the x equation, x equals to 4 plus y. 4 plus 5 over here, that means we have 9. We have x equals to 9 and y equals to 5. This is our ultimate solution for this given equation. Option number 9, 5. Option number B. Observe it once again. You can see how fluently it is being done from my end, and I expect this is the same from your end as well, because nothing complex is there. Very simple thing. 3 steps needs to be followed. Only thing needs to make sure that you don't end up with the wrong calculation. Alright, observed. Fair enough. Next question. Next question says that the two rails are represented by the equation. Now 2 equations are given and each of the equation is representing 2 rails. Something like this. Will the rails cross each other? Now in general you know that the rails never cross. If we have a train track or railway track, the lines will never intersect. The 2 lines will never intersect. Other than that, multiple lines might be intersecting, but the 2 rails never intersect. Over here, using this equation, you have to check whether this is the case here also or not. Whether these 2 rails will intersect or they will divert, or what will happen with this case. Many students might think, sir, we can go forward again using the graphical solution because this was the case we have learned in the first topic. No, bache, no, you don't have to go forward in that side. You have to just observe by seeing the coefficients of x, y, and the constant. I told you that you don't need to go forward starting solving the equation. This can be easily observed directly. A1 by A2, B1 by B2, and C1 by C2 is the thing which we need to find out. From here, A1 by A2, 1 by 2, 1 by 2, value of B1 by B2, 2 by 4, which is again ending up in 1 by 2. C1 by C2, minus 4, minus 12, minus 4 by minus 12. So this is minus got cancelled, 4 dividing 12, so 1 by 3. 1 by 2 equals, so A1 by A2 is equal to B1 by B2. But this is not coming out to be equal to C1 by C2. This is not equal to C1 by C2. I hope you remember this case. This case was the case of inconsistent solution where the two lines were parallel, and hence I can say that the given two equation over here or the given two rails will never intersect. They will remain parallel. That's a happy thing. The train will be safe. All right. So why I kept this question in between? So basically you are solving for substitution method. So you might have a tendency, let's start by solving the equation. Every time don't go forward by solving the equation. First observe the equation and then realize whether we will be having a solution at the first place or not. Next problem over here. Solve the two given equation and hence find the value of m for which y equals to mx plus 3. I'm not able to understand the question, sir. The problem is very simple. They are saying find the value of x and y from the given two pair of linear equation. Once you have the value of x and y, you can replace the value of y and x in this part, and then you will again end up with a linear equation, simple linear equation in terms of m. You will find the value of m from there. I hope you can try this one. A very simple part. I want you to try this one. There is one case which I want to mention using this one. What is that case? Over here, 2x plus 3y equals to 11. 2x minus 4y equals to minus 24. Now, things are simple using the substitution method, but sometimes what happens if the coefficients are large enough? The process becomes very hectic and very boring at the same time. Who wants to do the calculation? Basic calculation which calculator can do. I don't want to engage in the extra steps which are not required. Is there another method which can help this part? Because for the graphical method, we had that nature of solution by observing A1 by A2, B1 by B2. We got the understanding whether the lines were unique, having unique solution, or were parallel, or were having the infinite solution. Here, can we proceed by any other method? For you, there is a homework that you will try using the substitution method and find out the value of m. How? By solving these two equations, getting the value of x and y, and then putting up the value of x and y in this given equation, finding out the value of m. That is the part which you need to do. By my understanding, the correct answer would be -1. So try on your own and check whether you are getting the answer to be -1. But the point I was making over here, there is another method which can make our process more simple. And the method relies on making the coefficient same. The process relies on making the coefficients same. If the coefficients are same, then the solution can be very easily found out. And this method is called as elimination method. Substitution. Basically, a player was substituted for another player. Y was replaced with a part which was having x in it. This time we are going to eliminate. We do not want either x or either y. So let's see how we proceed over here. Elimination method, how does it work? Easiest method among all of the three. We have been given these two equations. 2x plus 3y equals to 8, 4x plus 6y equals to 7. Alright, I told you elimination method works well when the coefficients are same. Coefficients of what? Any of the coefficient, either the coefficient of x are equal or the coefficient of y are equal. If that is the case, then the elimination method will work really well. So every time that will not be the case, the coefficients are equal, but you can make the coefficients equal. How? This is 2x plus 3y equals to 8. in this scenario, what I can do, I can multiply the given equation. I can multiply the given equation by 2. What will happen in this scenario? When you multiply the entire equation by 2, we'll have 2 into 2x, that means 4x, plus 2 into 3 is 6y, 8 into 2 is 16. We have got a new form of equation. But as I mentioned, it's not an equation, it's the same equation. When you go on plotting the graph, you'll get the same line. Over here, it's the same equation, just it has put up some makeup, just to fool you, Now, this equation is there. We had the other equation, so let me write the other equation as well. The other equation is 4x plus 6y equals to 7. Fair enough. Now, this is the case. What we need to do, there's one thing which I want you to observe over here. 4 upon 4, 6 upon 6, 16 upon 7. What is happening, sir? A1 by A2 equals to B1 by B2, not equal to C1 by C2. Will you find the solution at the first place? No, you cannot find the solution, because elimination method will also not be able to provide a unique solution for this scenario. What will happen? See, how elimination method works. Elimination method works on making the coefficient same. When you make the coefficient same, then you eliminate. I'll subtract this equation from this. So 4x minus 4x, it will cancel out, we'll get 0. But while doing so, the same method, 6y, 6y, these two are also same. They both will be eliminated. Neither x will remain, neither y will remain. What we'll be having, for what we are doing this calculation for? Because any one of them should be there. Elimination method, I told you, you will eliminate any one of them. We have this elimination, 2 teams are playing the elimination round. There's a semi-final is the elimination. One team will get out, one team will remain, the winner, right? And will go to the next group. And in this scenario, if the coefficient are same, neither one of them will remain. So elimination cannot happen in this scenario. So we need to change the scenario. Let's observe this equation over here. Now, this might be scary for some, because wherever we have a fraction, people get scared. So you observe from your end, how can we form the coefficient same? It's not that complex. We have x by 2, x. Either I can divide the second equation by 2, but I don't want to divide. I am not a fan of dividing. I like doing multiplication. 2y by 3, y by 3. So if I multiply the second equation by 2, it will also convert it into 2y by 3. So let's start doing that. Multiplying this equation by 2. So what we'll be getting? We will be getting 2x minus 2y upon 3 equals to 2x minus 2y by 3 equals to 6. Now, this is same as this one. Let me write the first equation. First equation is x by 2 plus 2y upon 3 equals to minus 1. I told you, in elimination method, first step is to make the coefficient equal. Once you have made the coefficient equal, observe the sign. If the signs are opposite, second step, if the signs are opposite, you don't need to do anything. You just simply need to add the two equations. When you add the two equations, this will be positive, this will be negative, and both will be cancelled out. We need to add these two now. X by 2 plus 2x equals to, on this side we need to add minus 1 plus 6. We have converted the two equation into a simple equation in one variable. Now from here you can find out the value of x. Taking the LCM of 2, this is x plus 4x equals to minus 1 plus 6 come out to be 5. So x plus 4x is 5x. 5x equals to 5 into 2, 10. From here the value of x comes out to be what? Simply 2. We have find out the value of one variable, so another variable can be easily find out. You can put up the value in any one of the equation, This final step, first step to make the coefficient same, second step to check for the sign, and third step is to find the Simple, one variable, and once you have find the one variable, the fourth step is to replace the value in the any one of the given equation, find the second variable. This I am leaving up to you, that you will able to find the value of y by putting up the value of x in any of the two equation, because answer will be the same either you put in the first one or the second one. It does not matter at all. Fine. This was elimination. This was elimination. Now, whatever we are doing over here will not be of any use if you don't understand how to solve word problem, because as I started the chapter, I mentioned to you that this chapter is much more fun because it helps us solve the real life issues. It helps us solve the real life issues. So real life issues are of this sort. Sometimes they are. So here we have a word problem given in English form. You have to convert this English form and form a mathematical form. You have to create a mathematical equation and ultimately try solving it. The equation over here given says 5 years ago, Nuri was thrice as old as Sonu. Two friends or something, I don't know the relation. Nuri was thrice as old as Sonu. Fine. So let's talk about 5 years ago. 5 years ago. 5 years ago. What was the case? If I say Nuri, I can say we can assume it to be y and Sonu to be x. One being y, another being x. Now, we have thrice over here. Why I'm explaining in this such a manner? Because I know word problem, wherever word problem come, people go on one step back, because they're scared. Sir, this is a difficult task. I'm not pretty sure how can we go forward. That's why understand the basic approach, because there is no formula which you can apply over here. More and more practice you would have done, better you would have got by forming an equation. So one being y, another being x. The relation is thrice. 3 has to be multiplied, but on which side? For this you need to understand who is the elder one, who is the younger one. Nuri was thrice as old as Sonu. So Nuri is old. So she is the elder one. Who is the younger one? Sonu. So where should we multiply such that the beam balance come on balance? I hope you are realizing this part. Y is equals to, I should multiply 3 to the Sonu side so that the age becomes equal. Y is equals to 3x. One equation we have got. Moving on. 10 years later, after 10 years, now what will happen? This was 5 years ago. Now, we have assumed the y and x for 5 years ago. Now, how old are Nuri and Sonu? This they might be asking for the present time. We have assumed for 5 years ago x and y. Now, 10 years later, 5 years ago, after that 10 years later. So, writing over here for 10 years later. What will happen for x and y? If I am today 10 years old, what will be my age after 10 years? 10 plus 10, 20, sir. If you are today 18 years old, what will be your age 10 years down the line? 28 years. So whatever be my age, I would have to add 10. So 10 years later, I need to add 10 to y. That means y plus 10. And same I will be doing for x plus 10. This is the age after 10 years. Now we have to see what is the relation after 10 years. So 10 years later, Nuri will be twice as old as Sonu. This is very obvious. Where we need to multiply 2? On the Sonu side, because Sonu is the younger one. Now we have got the second equation. This time there is something which we need to do. We need to open up the bracket and form the equation correctly such that we can do the solution. So y plus 10 equals to 2x plus 20. From here, I can write the equation as 2x minus y. This 20 going on the other side. So here it comes to be negative. So minus 20 plus 10 minus 10. We have the equation over here. One equation is y equals to 3x. Another equation is 2x minus y equals to minus 10. So basically I can write this as 3x minus y equals to 0. And another scenario is 2x minus y equals to minus 10. These are the two equations which we have formed using the word problem. So the word problem over here, word problem over here would be taking an additional step. We'll be taking our brain creativity, the imagination to form the equation. If we have reached to this step, after that the everything will be again repeated using the algorithm. But for this there is no algorithm as such. Why I am saying so? Because this totally relates how well you can comprehend the given statements. If you are comprehending it well, then things will be very comfortable. If you are not, then you will end up with the wrong equation. Whatever effort you take solving the equation, that will be a waste for you. That will be a waste for you. So here we have the given two equation. We can solve them using the elimination. Now is the time you can understand elimination better. What I told, first thing, make the coefficients same. Coefficients are already same. So one thing is sure, I can straightforward go for elimination. If the signs are same, you have to change the sign. How? This is positive, so I'll write negative. This is negative, I'll write positive. This is negative, I'll write positive. Why I'm doing so? This basically means I'm doing the subtraction of the two equation. Previous case where the signs were different, I told you don't need to do anything, just simply add. So when you add, plus minus will cancel out. But since the sign are same, this time I have to make subtraction such that there is a change of sign. One is negative, another is positive. And one of them will be eliminated in this manner. This is eliminated. We are left with 3x minus 2x, which is x. X equals to simply 10. From here, you can put up in this value over here and find out the value of y, which will come out to be 30. And hence we have the answer. X being 10, y equals to 30. We know that Sonu is 10-year-old, Nuri is 30-year-old. As simple as that. I hope you realize. Please observe once again the problem on your own. If you are not able to form the equation, might be difficult. Once you have formed the equation, things are very simple, because in this chapter, the chapter name is pair of linear equation, and there are three methods which you have learned. But the method are just a tool, just like mathematics is a tool to solve the real life problems. Alright, so here we have the problem and here we have the solution. Next problem over here. Meena went to a bank to withdraw 2000. Another word problem. See what kind of a cases can be there, and you will get the interest in maths that okay, maths is also relating to our real life. Few students have this problem. So we are learning polynomials, we are learning this chapter, we are learning construction. What's the use of it? There is a use of it. There is a use of it. That's why you are learning at the first place. Meena went to a bank to withdraw rupees 2000. She asked the cashier to give her 50 rupee note and 100 rupee note. So total amount she was having after withdrawing would be what? 2000. In what currency note she got this much amount? In 50 rupee note and 100 rupee note. Fair enough. Meena got total 25 note. If I say the notes of 50 currency was X and Y would be representing for 100. X representing 50 rupee note, Y representing 100 rupee note. So the sum of X plus Y, that means the total number of notes she was having is given to me as 25. Writing the equation. One equation formed very easily. Second equation. Find the how many notes of 50 rupee and 100 rupee received. This is very simple. If I am having 10 coins of 1 rupee, 10 coins of 1 rupee. So how many rupees do I have? I'll simply multiply 1 with 10. 1 into 10 will give me 10. If I'm having 10 2 rupee coins, so I'll multiply 2 into 10, 20, right? The same I have to do over here. If I'm having 50 rupee notes, how many? X. So I'll multiply 50 with X. This is the total amount in terms of 50 rupee note. The same I had to do for 100 rupee note. For 100 rupee note, I need to multiply 100 with the number of note, which is Y over here, which we have assumed. Now, this is 100 rupee note. This is the amount coming from 100 rupee note. This is the amount coming from 50 rupee note. I need to add both. When I do the addition of both, the total amount already given to me 2000. Here we have 2000. Once we have got the second equation, now things would be very simple, and from your end you can calculate by multiplying either by 50 or by 100. What will happen by multiplying 100 or 50? The coefficient of either X will become same or the coefficient of Y will become same, and hence you will be able to solve the problem for value of X and Y, which is very easy to understand. Alright. So something you need to do from your end as well. As I mentioned, practice. So this was another case of word problem related to money. The previous was the different case related to age. So let's solve few more questions and then we are good to go. Here we have the next word problem related to the case of numbers. there would be multiple categories. There will be multiple categories of word problem. One related to age, one related to number, one related to geometry as well. How related to geometry? I mentioned we are having a triangle. You have to use the property of triangle in that manner. So let's not waste time, understand this problem. The difference between the two numbers is 26 and the one number is 3 times the other. One single statement, two information given. The difference between the two numbers is 26. So basically y minus x is equals to 26. Alright, y minus 6 is 26. So I am subtracting x from y. So which is the bigger number over here? Obviously y is the bigger number. Y is the bigger number. I am subtracting the smaller number x. Now they are saying the one number is 3 times the other. So there is a relation between y and x. So where should I multiply x? Sorry, where should I multiply 3? Because 3 times is there. 3 times is there. So where should I multiply 3? Obviously on the smaller side, so as to make the beam balance something like this. Something like this. So I'll multiply 3 on the smaller side, y equals to 3x, and we have the two equation. We have the two equation. Now, either you can go for the elimination or you can go for the substitution, because things are very simple. The coefficients are equal. We have been given y in terms of x. Let me replace this into this equation. So when we have given over here y equals to 3x, when I put in the above equation, so this is 3x minus x equals to 26. So this is 3 minus 1, that is 2x equals to 26, and from here x comes out to be what? X comes out to be 13. If x is 13, from here y will be what? 3 into 13, that means 39. We have the correct answer, option number C, 13 and 39. Such is a simple problem on the case of number. Number, we need to form the equation between x and y, basically the two numbers which we have assumed, and then using the second information about the number which they will be giving to you. Alright, this was the case. We have formed 3 cases of word problem: numbers, age, and the case of money or currency denomination. Alright, I hope you have realized this part. Let me take one problem related to the geometry as well. Geometry. Here we have the next problem which relates to geometry. The larger of the two supplementary angle exceeds the smaller by 18 degree. Now, few students would be clueless. Sir, supplementary, what does that mean and how does it relate to geometry? If you remember, supplementary angles are what? Supplementary angles are the one which are having the sum as 180. If I add the two angles, I get 180. That means that the two angles are supplementary. So if I have x and y, so x plus y is for sure the sum would be equal to 180. One equation formed. Very obvious. That is how the problem in geometry works. The problem in geometry will be using any of the property of the given figure. Property of the given figure. Next, the larger of the two supplementary angles exceeds the smaller by 18. Now, over here when we did the addition, it doesn't matter which one is the greater. So let us say y is the greater one. Let us say y is the greater one. So the larger of the two supplementary angle exceeds the smaller. So definitely the greater one would be having some extra amount compared to the smaller one. So how much extra amount? 18. So if I add 18 to x, I'll be getting the value of y. Y is equals to x plus 18 because y exceeds x by 18. And now we are having two equations. Again, in the similar manner, you can replace and find out. I am replacing the value of y. I am replacing the value of y over here and putting in the above equation. So this comes out to be x plus 18 equals to 180. See, it's not that every time I'm going for the elimination method. I can go for the substitution method as well. Both method can be useful in different scenario. Over here, both will work well. So 2x equals to, we have 180 minus 18, that is 162. So from here, the value of x comes out to be basically 81. So value of x is 81. If the value of x is 81, from here you can find out the value of y. Y value will be simply, you can observe, 99. We have the solution, option number A. Fourth case I have solved where I have used the geometry to answer the pair of linear equation. Pair of linear equation will not be asked isolatedly. You might use your imagination, you might use your understanding, you might use your understanding of mathematical chapter which you have already learned. That is how things will work in this scenario. So I hope you are comfortable now solving on the part of the pair of linear equation. Let me summarize what we have done. Initially we talked about why the pair of linear equation are important, why simple equation doesn't work, because there can be a complex scenario where we need two variables, and wherever we have two variables we will be needing a pair of linear equation to find a unique solution of x and y. Now there can be a unique solution, but sometimes there can be a case of parallel lines, or I must say no solution, and there can be a case where the two equations are same, so basically infinitely many solutions, and ultimately we reach to the two method which can help us to find that unique solution if possible. So we learned about the substitution method and the elimination method, but we didn't end the session with this much. We used word problem to understand how this chapter is important, because most of the problems will be asking you word problem. That's for sure. At least one problem would be there in the examination in this chapter which will be a word problem. So you should have your creativity or imagination and the concept of mathematics to frame a mathematical equation. After that, again two methods helpful for solving the equation. That is all we learned in this chapter, and as I mentioned in the starting, there was no clear-cut formulas. There was algorithm which you have to use ultimately in this chapter. Alright, I hope you had enjoyed this part. Even though if you haven't, that doesn't mean you have to skip this chapter. So make sure that you take up your textbook and do two things. Practice the solving of the equation by whichever method you feel comfortable, and framing the equation from the word problem. This is a very important task which you need to attempt from your end. If you are able to do that, that means you have mastered this concept, you have mastered this chapter. And from my end, that is all what I had. Hope you are having a great time. Enjoy yourself. We'll meet in the revision session of the next session, which is trigonometry. Till then, have a great time. Bye bye.